In this video, we're going to be proving the derivative for the inverse of tangent function is equal to 1 divided by 1 plus x squared. To do this, we're going to first assume the inverse of tangent x is going to be equal to y. Therefore, by definition, tangent of y will be equal to x. And with this definition, we can apply the definition of the tangent function of any angle within a right triangle, which is equal to the opposite side relative to angle theta divided by the adjacent side relative to angle theta. Therefore, if I construct a right triangle as such, and I assume one of the angles to be equal to angle y, the side opposite to angle y will be x, the side adjacent to y will be 1, and the hypotenuse will be the square root of 1 plus x squared. This comes straight out of the Pythagorean theorem, which states that a squared plus b squared is equal to c squared, where a and b are the legs of a right triangle and c being the hypotenuse of the right triangle. Therefore, the hypotenuse of the right triangle will be equal to the square root of a squared plus b squared, or in other words, the square root of the sum of the two legs of the right triangle squared. And now what we can do is just take the derivative on both sides of the equation, tangent y is equal to x, to obtain secant squared of y times y prime is equal to 1. Therefore, we can rearrange this to get y prime is equal to 1 over secant squared of y, which is equal to the cosine squared of y, which is also equal to the derivative for the inverse of tangent y. And the reason why for this is because we previously assumed that the inverse of tangent x is equal to y. Therefore, if we take the derivative on both sides, y prime will be equal to the prime of the inverse of tangent function, hence making this equation true. And we know the definition for the cosine function within a right triangle will be equal to the adjacent side relative to angle theta divided by the hypotenuse of the right triangle. Therefore, cosine of y will be equal to the adjacent side relative to y will be 1 divided by the hypotenuse, which will be the square root of 1 plus x squared. Hence, we can substitute cosine of y's value into cosine squared of y to obtain the square of 1 over the square root of 1 plus x squared. Then this can be evaluated to 1 over 1 plus x squared, hence proving that the derivative for the inverse of tangent function is equal to 1 over 1 plus x squared.